Hello, welcome back to the channel, and in today's video we will try to recreate the Frogger game, which was first published on Atari. As you can see, there are a few things here. We have the highway lane with the vehicles, and then the water lanes with the turtles and logs, and I will show you how to create those as much configurable as possible. Naturally, and then we have to get to those upper home slots for our Frogger to actually finish the game. And there's a timer. If it runs out, we die and we lose a life. So let's get to work. Let's start by setting up new project. So go to the Godot Engine Project Manager. This will just pop up whenever you run Godot. Let's find a proper place for our project. I'm going to create a new folder called this Frogger tutorial and select current folder. Renderer is forward, version control metadata is git, and let's create and edit. Let's switch to 2D, and I will start by bringing in all of the assets that we need. Those will be available in the repository. So if you want to grab those, go there, assets. Let's select everything that we need. And let's bring those in. Okay, let's go to project settings first, as we would like to set up our window, and I run it in 784 by 1000. Stretch is set to viewport. Perfect. It doesn't seem correct. By 1000, not 100. Okay. Another setting that we would like to add is, of course, to set the clear color to black. So let's search for clear, go to rendering environment, switch everything to black color. Perfect. Now, even though our game isn't grid related, we must remember that we're kind of working with a grid, because everything is going to be placed and moved in 64 pixels increments. So knowing that, let's create our main scene. Let's create empty node, and call this main. Let's save it, create new folder, call it scenes, main scene, and I will make sure to mark this scene as a current scene. Even though there's nothing there, it's perfect. It's perfect. So if you want to see how to actually play Frogger, you can search for a happy hooper. This is called Happy Hooper, right, online, and you can kind of see the game. You can see that we have these two, I don't know, sidewalks, probably pink and violet, that we start, and we have our frog that is incrementally hopping back and forth, and we have to cross the road, and if we hit anything in the road, we die. So let's actually start by placing in the correct places those two sidewalks. So to do that, I'm going to create new scene. To the scene, I call this for some reason median, but we can call it a sidewalk. Okay, let's save it and let's start adding stuff to it. There's not really much that we need to add. We only need a sprite. And for this, we have the median sprite. And naturally, if you're bringing pixel art, Godot will blur it for some reason. But let's switch the texture filter to nearest, and now it's sharpened. Okay, if we were to place that in our game, we could go to instantiate child scene or press Ctrl+Shift+A. Right, and first thing you see is that it's small, and also if I would like to stretch it for some reason to cover whole of the x-axis, right? Oh, sorry. Let's unlink that. It's gonna stretch the texture. What we would like instead is to have the texture kind of repeating along the axis. And we can do that. We can go to region in our sidewalk, go to sprite inspector, and here I can press region enabled, and then I can press edit region, which is gonna show me the region editor, right? Or what I could do instead is just provide the correct values. So let's see. First is that we set up the scale to bump it up to 4, and then the width is 260, and then height is 16. And that almost works, right? But we still have to edit our region to something like no, it's not going to work. Let's bring back the previous values. What we are missing though is repeat enabled. And now you can see that pattern being enabled across x-axis. Perfect, so we have our sidewalk. Now we have to place it in the correct place. And there are actually two ways to do it in Godot, because if I run it now, you can see what's getting rendered is the rectangle here with the blue or navy lines, right? And this is the 0, 0 point, and here is the maximum x and y point, and this is fine. You can use that to place it, to place everything in your game, because typically screen coordinates starts with 0, 0 and go to some kind of max x and max y. But what I tend to do instead, for my own calculation, and this is just me, you don't have to do it, is I place camera at 0, 0, 0. So this is now the center of our rendering, right? This is just me. You don't have to use the camera for that. Okay, let's start placing those sidewalks. So this is gonna be sidewalk bottom, and I set it to be 450, but yes, it should be 450, maybe even a little bit higher, but we can live with that for now. And then I'm gonna duplicate it and set the sidewalk middle, because the second one is gonna be in the middle, and I place it at 66, right? Okay, that looks correct. Okay, so this is our setup. Oh, I know what might be a little bit different. Sorry, the correct values are 418, and then this should be 43. Perfect. So this is our base setup, and in the next section we can work on our character and its movement. So I see you in the next section. Let's start working on our frog character. So to do this, we have to create a new scene, and we'll use area 2D as a root node. Let's bring in, of course, sprite 2D, and let's bring Frogger idle. Of course, first things first, it's gonna be blurry. Let's change that to nearest filter. Now it's way better. Rename it to player. Save it. And let's see, what else do we need? We will need the collision. Right. Okay, so add child node, collision shape 2D, new shape, new rectangle shape 2D, drag the handles to make it match to the best of our ability. Okay, and for now, this is it. We just have to make it move. Let's start by instantiating that scene here. Let's place this in its rightful place, which is, let's see, 0, 4, 1, 8. Also, let's bump up the scale, and we have our frog on the sidewalk. Perfect. Of course, it does not do anything yet. So let's start by adding some scripts. Let's go into a scene. Let's add a script. Player is a good name, but I would like it to be not in the scenes. We would like to keep it all tidy. So let's create new folder, scripts. Let's move it here. And let's have a short discussion about the folder structure in your project. So what I tend to do so far is create folders like assets, scenes, and scripts. And this is all fine for our scope of a project, which is rather small. And this is known as separating by type. But if I would be planning much bigger project, I would rather have a different approach, which is known as separation by context. Meaning, I would create probably folder like entities. Inside of it, I would create another folder. So maybe let's show this. Entities. I would create another folder here called player. And here, I would have probably folder like art, and then I would move the everything regarding the player related stuff into that art folder, and here I would probably create a new scene for the player, and of course the script for the player. And I would do that to keep everything regarding one context, meaning player context, in one place, right? Because often when you have to change something or fix a bug, right, you start digging by searching for a context. Oh, this is a bug or new feature related to a player. So everything that has to happen there is within the player folder, right? So these are the two approaches for how should you structure a project, and this goes way beyond game development. The same goes for front-end development, mobile or backend. You really have to figure out which way is more convenient to you for your mental model. Okay, let's get rid of that, and let's start coding our player. Okay, so what we will probably have to do is to stash the current player position. I'm just gonna say player start position equal to vector 2 0 4 1 8. And this is because whenever we go home or die, we have to move our player back to the start. What else do we need? For now, not that much. We need to set up the input map for our frog to be able to move. So let's add new action, call this up, down, left, right, and we can now press our buttons. So I can press plus, W, but also I can add another key to trigger that action, which is going to be up. Oops, not enter. Okay. Down is S, but also down. Left is A, but also left. And right is D, but also right. Cool. So we have that set up. Let's actually read that input. And you can do it two ways. You can do it in process. This is fine, but I tend to use input callback for our script. We don't need event. Let's do the standard thing that we have to do. And we're using isAction just pressed because one press translates to one single move of our frog. This is different from example from games like Mario where you press and hold. And in that case, I would use isAction pressed. Down, we need something I will call position candidate. And I'll explain why are we doing this shortly. Position candidate is equal to vector 2 down plus we need something that I will call position increment, meaning how far should we move with a single move. And I set this to 64. And why 64? Because if you take a look at our sprites, they're all based on 16 by 16 grid, but we apply scale of 4 to it, so 4 times 16 is 64. So that's why. Times position increment plus position. Okay. Let's do the same for all other actions. You can just copy that. Let's keep our indentation in order. Okay. The function signature doesn't match the parent. Yes, because there's an event here, right? Now it's correct. Okay. And we will also have something that I will call new position. I will say that new position is equal to position candidate. Yeah, okay. Let's try and run it. Oh, and we can just say if there's no position candidate, just return. And it doesn't work because we're not doing anything with it. So here in process, I can say this starts as vector2 0, and if new position is vector2 0, then return. And what we could just do is say position is equal to new position. But what that gives us, we can move, but there's no like movement between the points of increment, right? We're just moving left and right. So what we actually have to do is to linearly interpolate between 2 points, our current position and new position. And instead of us just snapping violently from point to point, what will happen is this is a time, which is like the time in our game, and this is our position. And we would like to go from here, for example, to here. Instead of just snapping to it immediately, we will interpolate with some weight, and this is going to incrementally apply the change to position over time, each and single frame. So we have this notion of very fluid movement. And to do that, I love using Paint when explaining stuff. It's perfect, the best tool ever. To do that, we will do lerp between parent position, which is starting position, new position, and the weight of 0.4. Yes. This looks correct. So let's try now. You can see that now we're moving fluidly. And of course, if I decrease the weight, you can see that our movement is slower, right? Even more so. Right, you can see how slow we are. So this is basically our speed, right? So we can export it and use that. And that's pretty good, but there's one problem. We're not using the delta time here. And this time is time between frames. So we should actually make our speed dependent on that, because let's go back to Paint. Right? If I have very fast computer, the input's gonna be called very often. And each time we're applying the very same speed to it, or the same linear increment, right? But if my friend has a very slow PC, then the calls are gonna be more separated in time. And each time I'm still applying the same increment to our linear interpolation, meaning he will be moving way faster on his screen than I am moving with the very same code and game. So we have to change it a little bit. So if we call this times delta, you will see that our frog is very slow because the delta value is very low. So let's try and bump it up to a bigger value. Okay, that well, that's way too big. Let's find the right value. Okay, 40. That feels about right. Cool. So now we have the basic movement. The one thing that I am kind of missing right now is the fact that our wonderful frog is not is actually not turning. So what we can do is just grab a reference to a sprite. So go here, and I'm clicking, dragging, and holding control, and that's gonna give me an already reference to a sprite, and I can say something like this: sprite 2D, rotation degrees, and I believe there's one more thing that we're missing. Yes. Well, does it matter? Not really. Let's see. This should be set to 0. Then sprite to the rotation degrees set to 180. Sprite to the rotation degrees is set to 90. And sprite to the oops. To 70. Okay, let's try this now. Okay, this is, as you can see, this is backwards, right? So we need to change those. So this is 90 and this is 0. No, sorry, this is collapsed. This is 180. This is 0. This is 270. And this is 90. Perfect. Now it's turning into the right direction. So I believe we should finish this section now. In the next section, we'll do some improvements to the movement of our Frogger. So in this section, we should improve the movement of our Frogger a little bit, because if we run it, we see two problems. One problem is that we can go outside of the camera bounds. The second is that it is possible to press two buttons almost immediately and go diagonally. So let's try and fix those. So to fix the movement outside of the camera bounds, we need a reference to our camera. So let's do, we could do an export. Camera 2D. And we can also define something called camera bounds. And we need left, right, and left, right, and bottom. Because we don't care about the top, because that's where the home slots will be. So in our ready function, let's get rid of that comment. We can just say camera rect is equal to camera get viewport rect, and we can set up the bounds. So camera bounds, mixed use of tabs and spaces. Why? We'll do this. Camera bounds left is equal to camera position x minus camera rect size x divided by 2. Camera bounce right is simple because this is just camera bounce left plus camera rect size x. Camera bounce bottom is equal to camera position y plus camera rect size y divided by 2. Perfect. And now we can use this to limit our movement. So here in our input we can add another if position candidate x is greater than camera bounce right, or position candidate, or by the way, this or is the same as that one. This is just synthetic sugar over that well-known symbol. Position camera candidate x is less than camera bounce left, or position candidate y is greater than camera bounce bottom, return. So if position candidate x is greater than camera bounce right, or position candidate x is less than camera bounce left, or position candidate y is it should be, yes, greater, because you must remember that y-axis is directed like this on the screen. This is facing down. Okay, cool. So let's see whether that works, and for it to work we have to pass the camera reference to our player, drag and drop it, and now I cannot escape the bounce, right? Cool. We should, because this place is the place for our UI parts, we should probably not allow our frog to move outside of the bottom sidewalk. So probably what we need to do is, let's see, sidewalk bottom is 418, right? And so this all has 500 because the height is 1000. So this is 418, and this has a size of 64, meaning here is so we should probably add 64 to that, minus 64 minus, we could use the position increment, right? So I can just go here and say minus position increment, and now we're not able to really go outside of our sidewalk. Perfect. The other thing to handle is the problem that I presented. If you press things immediately, right, the input is recorded twice. So let's try and fix that. There's a simple way to do this, maybe not very elegant, but we can add a simple flag, should not process input, set it to false. And this is different than right? This is inbound function that calls to the engine, and we don't want to do this. In that case, we'll simply block the input transformation and calculation by a simple Boolean flag. But this function can be used when you, for example, would like to stop processing input altogether. So let's see. We have the lerp. Now, first we'll round our movement. We can take the length of that vector and say probably need this, right? If that's smaller than, for example, 0, 0, 1, you can say position round position. So rounding up, and this indicates that our oops, can get rid of that. This if basically indicates that our movement has stopped, right? That we're at the next point already. So we can say we finish the movement, so new position is again set to, don't need to set it to vector 0, just need to say should not process input false, and then else if should not process input is equal to false, we can restart the movement. Okay. And I don't think it helps really. No, because it happens too fast. Well, okay, we will have to live with that ugly hack. But there's another thing that we'll have to add to make it almost complete. And this is, we'll go to the player and we will add animation player, and we'll set up simple animation and call this leap. Because if you take a look at our assets, we have frog idle and frog leap. So what we will do is we'll create a animation, very simple animation, set the length to 0.4. We don't want to autoplay, we don't want nothing. And let's add track, property track, sprite 2D, texture. Let's insert the key at 0. Insert another key at, I believe this is 0.1. Yes, and then the final key at 0.4. Okay, and this is going to be very simple. We will just change that to frog leap. Perfect, and do not make it linear, make it cubic. And this is pretty much it. This is the whole setup for our animation. If we play it, you can see how it looks like. And I can go back to the player and here. So basically we don't need that because it doesn't impact anything. But this is fine, we can live with that. This is not a game-breaking feature. We can say animation. Oh, we have to have the reference to animation player. So let's get that. animation player, play, leap. Okay. Now our frogger is moving like a proper frog. Perfect. So we have our movement pretty much set up for our player. Next task is to start working on the highway lanes and then the water lanes. So I'll see you in that one. Let's handle the highway lanes, right? So we have to have a way of spawning the vehicles traveling along the x-axis, and I want it to be as configurable as possible. Let's go to main, let's add a child node, and this is just for grouping other nodes. Empty node, move it outside here, and I'm going to call this highway lanes. And then we will create a new node, new scene, to the scene, and just call it highway lane. And these are going to be responsible for spawning the vehicles. So we also need a vehicle lane. Just a vehicle, right? So let's create new scene, and this time this is going to be area 2D, and I'm going to say it needs a sprite to represent the vehicle, and it needs a collision shape 2D, and let's call this vehicle. Save. Okay, now we can look into it. So let's set any kind of sprite here, say this one, go to 2D. Let's start working on this texture nearest when it comes to filter. Let's see, do we need any kind of other transformations? Not really, but what we need is a collision shape. So let's give it one. It doesn't have to be 100% precise. With this is good enough. Okay, and we have a vehicle, and we need a simple script for it. Let's go to scripts, open, create a script. Let's get the sprite reference, because we'll be changing the sprite based on the vehicle type. Let's give it a class name, because this is always a smart thing to do. Vehicle, and set texture 2D, and we'll apply this to the sprite 2D. Perfect, this is all we need when it comes to vehicle. Cool. Let's go back to our highway lane. And let's add a script. Of course, change the directory. Perfect. Let's start by adding the class name. So this is highway lane. Let me drink some water. Okay. We will definitely emit a signal here. signal is going to be player hit by vehicle, so that we can use this to kill our frog. Direction, this is, do we need it? No, not really. We need direction like this one, and we can add a comment here. One for left to right, -1 for right to left. Okay, we need vehicle scene. Bar vehicle scene. This is simple, we can just find it here, drag with control drop, and it's gonna preload that scene, and this is of type fact scene. Okay, other things that we need. We need the vehicle texture to know what type of vehicle to represent in that lane. This is just texture 2D. We need information about how many vehicles should be presented in that lane. We need to know what should be the distance between those. We need to know the scene. And we need something called movement X limit. And I'm going to set this like this. And what it is right, so here is our game screen, and then this is our lane, right? And what we will do is we will take our vehicle, spawn it off the screen, move it across the screen, and then when it goes outside of the screen, we'll not despawn it, we'll not call Q3 on it, but rather what we will do is we will move it back to its starting position, right? So that we don't have to instantiate and de-instantiate the vehicles every single time. So basically, if you instantiate some entity in game engine and you can somehow reuse it, maybe change its position, maybe reconfigure it, instead of freeing it and then instantiating new one, it's pretty much always better to do it this way, because the process of instantiation is rather heavy when it comes to the resources it requires. You have to find a place in the memory to place all the information about given entity, and then you have to configure it and like bootstrap it in an engine. So it's better to reuse the stuff that we have. Okay, and as you can see, we have rather extensive configuration here, but this is making our vehicle lane rather elastic for our needs. And we'll also have the vehicles array to keep all of our vehicles. Okay, let's do the ready function. Let's do start point x is equal to movement x limit times direction, and we will have to keep those in sync, but this is okay. For I in vehicle count, vehicle is equal to vehicle scene instantiate as vehicle position is equal to vector 2 minus movement x limit plus distance between the vehicles times I times minus direction and then 0 for y. Okay, so this is the starting position for our vehicle. We have to take in account the movement x limit, but like on the other side, and then the separation between our vehicles, because they're, again, paint, because I love it. So we have a lane of vehicles, right? And they are placed in a distance from each other. You can, with this variable, you can make them place themselves closer to each other or spread them more apart, right? And when placing them in the start, we have to take into account that distance. So first is at the movement limit x, and then we offset next vehicle back. Okay, cool. We will change the scale. Also, we will set up the signal listener. We'll create a function for that. Now we'll just print crash or something like this. Okay, we can add a child. We can set the texture. And let's add this to our array. Cool. Now we need to move those. So let's grab process delta, and for vehicle in vehicles, basically we could also do get children, but also having a reference here is fine. Let's calculate new position. And let's check whether we hit the movement limit. And if you don't know what ABS is, this is absolute. I mean, this operation will always have a positive value, and this is because we can move from left to right or right to left. And also here, what we can do is simply check whether the area that we get here is a player. And to do that, we have to add the class name of a player here. And let's emit that signal. That's it for now. Let's try and place our highway lanes. So here I'm gonna instantiate a highway lane, and let's see what it is required here of me. Let's set the vehicle. Let's leave it all. Oh, I believe that. Oh, the direction is here. Okay. Let's set the direction to -1. And then we have to set the movement limit also to minus here. Vehicle texture, let's bring the first one, right? And let's see. Let's set the position 0, 3, 6, 4, just above that. And let's try and play it. And we have our wonderful vehicles. I think something is wrong. 1, 2, 3. Okay, well, they should be coming back. One, and then there's only 2. Let's see what is happening there. To fix that issue, what we need to do is simply bump up the movement check limit, because sometimes this incrementation goes past the limit, so sometimes we just skip that check. But if we just bump it up to 10, I'm pretty sure we should always get the same result. Perfect. So let's set up the rest of our lanes. Let's see, I'm gonna duplicate this, change the position to 300. Then let's see the vehicle texture, that one. The vehicle count is 4, and again you can change it to your own needs. I do the distance to be bigger, 250, and then this is 480 and 1, and this should be good for our second lane. And as you can see, we can manipulate those values to create different experiences. Then highway lane 3. That one minus, oops, -1, -480. Let's see. Distance is 300. Vehicle count is 2. Speed is 200. And these are all just examples. You can of course set those as you like. 2, 3, 6, and as you can see, the lanes are spread in an increment of 64. Again, very important to remember to set everything correctly. 3, the 4th car, this is 1, and 480. And also, if you'd like to see the bigger offset between car disappearing and popping up, you can just bump it up, example like that. Okay, and 5th lane. And I set this to 2, 230, 160, -400, and -1. And make sure that if you have a minus here, then also a minus here, just to keep everything in sync. let's see the transform. This is 172, and this is then 108, right? Right. And let's see it in the works now. And we have our wonderful highway lanes running. Perfect. Next, we'll work on logs and then on turtles. So let's move to the next section. With our highway lanes working, let's work on our water lanes. So first thing I'm going to do is actually add a water. And this is going to be simple. We'll add area to D. Let's save branch as a scene, go to scenes. Let's call this water. Name this to water. Also rename it here. Maybe move it to the top. And let's see. We will need a sprite 2D and collision shape. This is pretty much standard. Collision shape 2D. Let's move it here. In this case, I'm going to apply scale here. And then we need to make it a region, and let's say repeating enabled, right? But it doesn't really matter in that case. And edit region to be 16 by 16. Perfect. And let's match it with collision shape. So new rectangular shape, drag the handles, and this looks correct to me. Perfect. Do we need a script? Yes, we need a very simple script that will allow us to detect what is what, and just give it a class name so that it can be casted. And then we can go back to our water, to our main story, and place our water like this. Let's see. The scale is set to 13 and 6. Sorry. 13 and 6. And I placed it at minus 181. Cool. So this is our water. Let's see. And this looks correct. And we can start working on our water lanes. So let's add a new empty node that we can use to group all of our water lanes. And we will start by creating a new scene, 2D scene, call this water lane. We'll have two types. There's gonna be water lane, meaning the lane with logs, and turtle lane, which is the lane with turtles. And to do that, we also need, let's save this with another scene, which is going to be log scene. Let's call this log, and let's save this. And finally, our log scene gonna be built with log end, log middle, and log start. So let's create those scenes. These are going to be a little bit more complicated. Let's start with log start. So as a root node, I'm gonna select area to D, and I'm going to add a sprite, and I'm going to add collision shape. and let's save this as log start. Okay, so we have log start here. Apply it as a sprite. Texture filter nearest. Actually, this looks to me more like log end. So this is, yeah, this looks like start because I'm looking from left to right, just like you would read stuff. Okay, let's see. Do we need anything strange here? Not really. All we need is a collision shape. So let's go with rectangular one. Let's place it correctly here, and this is our log start scene. Then we can do log middle scene. So new scene, area 2D, you know the drill, add a sprite, add a collision shape. For the sprite, let's do log middle. Let's call this log middle. Let's see, it's blurry, of course it is. Save it. Add a shape here. This and this. Okay. Last scene. Area 2D. Add a sprite. Log start, but in our case we'll call this log end. Cool. We need collision shape. Okay, and perfect. Okay, that was a lot of scenes to add, but we separated it for a reason so that we can make it configurable. So we have log, log end, log which is just empty node 2D, log end, log middle, log start with sprites and shapes 2D. And to make it work, let's go to log. And we'll need to code our log. Let's get rid of everything. So we have class name, log. We'll export something that I call middle section length, right? Because we will have, always will have log start, then log end, and then middle section length, and then middle section length is how many log middle sections do we have, meaning how long our log actually is. So this, in this example, the middle section length is 4, and then on the edges we have log start and log end. We need reference to scenes. Let's grab those. Then we have okay. We have the speed to be set, and we have log section length, which is also 64. Let's move it here. Okay, and basically what we need to do is instantiate it in onReady. So log start, set the scale, set the position. Perfect. Then we will need to instantiate the middle sections. Set the scale. We need to add a child, right? This should be vector 2. And set the position. And to set the position correctly, we need to take into account the log starting position and the log length. Perfect. With that, we can spawn the log end. Set the scale. And set the position. Make sure to really think of why and how the starting position for each section is being set, right? Really make sense of it. So in that case, you need to know how long is the section of the middle, right? And we also have to take care of the log section length. In that case, we take the starting position, then we add the length of the middle section, and then we add the half of the log section length. Because when setting these things, you must remember that if we have a, if this is the start and the middle section, and we'd like to find the position of the end section, right? The position of the end section isn't here, right? Because we also have to add the position of the end section is really here. So we have to add that half a length of the section, right? Our origin isn't here, right? It's here in the middle. The same goes for the start and the middle sections. So always remember that when you're placing stuff, you're not placing them on the edges, but you have to find the middle position for any scene to place it correctly. Or you can just move the origin, but this is way better. Okay, so now we have logs set up, and we can test this by simply trying to instantiate a log somewhere here, right, with middle section set to 3, And here we have our log. Perfect. Let's get rid of that. And we have to go back to our water lane. Let's see, where is it? Water lane. Let's add a script. Place it in the right place. Okay, and also here we need some configuration. So this is class name, water lane, and let's first define the logs length, and in our case it's gonna be 444. Then we need distance between logs. We need speed. We need movement x limit. We need their movement direction. And it's gonna be the same as in highway lane. 1 is from left to right, -1 is from right to left. We need reference to a log scene. And reference to our logs. You can be more specific and say that this is an array of log. Let's set everything up. So we'll need to track the index, calculate the starting position, movement direction, and 32 is just the half of the log length. And you can see, oh, no magic numbers. Well, okay. I could say just because we really shouldn't have magic numbers. Okay. We need to instantiate the log. Log scene instantiate as a log. We can set the middle section length to be log length -2. And we can add a child log. And then we need to start tracking things. We need to know the previous log position to know where to place this log. This is minus movement x limit if index is 0, 0, else logs index -1 position x log length times half log length plus distance between logs times minus movement direction plus previous log position. Right, so again we need to find the middle of the current log. So set the proper position length, right? And yeah, this should be correct. Then we have to set the log speed. Or do we? No, not really. Index, increment the index and append the logs. And then we need to make them move. So again, process delta for log in logs, new position x is equal to speed times delta times movement direction plus previous position of the log. And again, you can check for the absolute value of the new position. Let's set it to 10. This is pretty much the same code as we have in vehicle movement. Okay, let's see where this works. So let's add a water lane. And let's see what should be the position of that. Minus 30. Let's try this. Why does it state it is nil? For logs. Oh, that should be. Let's see. Log length. Let's try this again. And what we have is 3 logs of the same length. But if we change this, let's see what happens. Oh, 2 is too small. 3 is like the minimum, right? So let's see where this works. Or actually, 2 should also work. Right, because this is just the start and the end. Cool. Perfect. And we can increase the distance between the logs. And the speed. Nice. So this is how we can create the water lanes. In the next section, we'll handle the turtles. See you there. So we have water lanes completed, but in our game, there also should be turtle lanes. So let's handle these. Let's see. Let's start by creating a new scene, 2D scene, call this turtle lane. Save this. And we also need a turtle itself. So let's see. New scene. This is going to be area 2D. Let's call this turtle. And save this. Let's go to 2D. We'll need a sprite. We'll need collision shape. And we will need animation player. Let's start by adding the sprite, turtle 01 is fine. Texture filter nearest. Let's see, we need to add the collision shape, obviously. So let's add that. And something like, oops, something like this should work. Okay, we need to go into the animation player to set our animation. Let's call this swim. Add track, property track, sprite 2D, texture. And our length is going to be 0.9. We'll set this to autoplay and looping. And let's insert keys. This should be in time of 0, and that should be turtle 1. Then it should be 0.3. Sorry. 0.3 and then 0.6. We have turtle 2. And then we have turtle 3. And all together what we get is our nice little fella swimming. Perfect. And we can also change this to cubic, but it really doesn't matter in that case. Cool, so we have that. We need to add very simple script. Let's place it in scripts. Let's add a class name. And we need onReady reference, so let's get rid of that. For the sprite, let's call this set sprite rotation degrees. Perfect. And we can go into our oh, we're gonna need another thing, because if you take a look at the game, there's one very important thing. Take a look at the turtles. I'm not gonna add the functionality of them swimming underwater, but they're swimming in sections like 2-2 separation 2-2 or 3-3 separation 3-3, and I would like to make it configurable, so maybe 2-2 3-3 4-4. So we need something called turtle section. So let's start with that. Scene, new scene, 2D scene, call this turtle section. Let's add a script into scripts, but it should be named turtle section. Perfect. And save the scene in scenes. That's correct. Add a class name. We need the reference to the turtle scene. Yes. Let's add a turtle count. Let's add a movement direction. Again, from left to right, right to left, right. Function ready. Let's add the total, I don't know, dimension or I don't know, length, size is good. Section length is turtle count time turtle size, and then for I in turtle count I can do instantiation turtle scene instantiate as turtle scale, and then if movement direction is equal to 1, we need to rotate our sprite. And we need to set the position. So this is turtle position x equals turtle size divided by 2 minus turtle size times I. And then also we need a simple function here. So basically we can say this. Perfect. Let's see whether this works actually. So let me get back to main scene. And let me add a turtle section here. Let's see. And we have 3 swimming turtles. Perfect. So if we know that the turtle section is working, then we can start working on our turtle lane. Let's add a script. Let's place it in scripts, and we should move those previous scripts also into that folder. Let's add a class name. We need a reference to turtle section scene. And you can actually see what's Godot really about. We're breaking this very complex entity of a turtle lane, and we see, okay, it has a sections, and each section is built of single turtle. So we combine the turtles into a sections and then sections into a lane to complete given feature. So when you look into implementing something into a Godot, you would like to break it down into the most simple entities and scene, and then combine those like Lego bricks together. Back to the code. Let's preload that. So that's the turtle section. And let's export some configuration variable. Distance between sections. Speed. Turtles sections. Turtle sections. Lengths. 4, 3, 4, 3, and 2. Movement X limit. Movement direction. Okay, and we can keep the reference to turtle sections. Let's instantiate that. Let's use index. calculate the first starting position. It's minus movement x limit plus turtles section length times 32. We have to define this half turtle size times minus movement direction, and for section in turtle section length, we instantiate this and cast this to turtle section, and we have turtle section. Say turtle count is equal to section. Say turtle section movement direction is equal to movement direction. We add the child. And we calculate previous turtle section position as minus movement x limit if index is equal to 0, else we take it from the previous turtle section. We calculate previous section length, which is 0 if index is 0, else turtle section index minus 1 get sections. Section length divided by 2, and finally we can set the turtle section position x to be previous turtle section position plus distance between section plus previous section length plus section times half turtle size times minus movement direction. Again, a little bit complicated, right? But take a good look into how we instantiate and calculate the position of turtle section. We need to take into account the previous turtle section position, and then we need to add the distance between the sections plus previous section length plus current section, right, which is basically section length. That's how it should be named, so let's rename it length times half turtle size, because we need to know how far from the edge we are, and then we apply movement direction. We can add this to turtle sections. And increment the index. Okay, for the movement, this is rather simple, thankfully. And then we also do the limit. Cool. That should be all. Let's see where this actually works. So let's go back to main and let's add a turtle lane. Turtle lane. Let's see. Let's give it the standard values. Let's place it somewhere like 222. And let's see where this works. Perfect. We have our turtles. So let's finalize this by adding all the turtle and water lanes that we would like to have. So water lane 2. Let's see how I configure this. Size is 2 with 5 and 3, 180, 200, minus and minus, and the position for this is minus 94. We have turtle lane. Then we have another water lane, which is all fours. Why can't I change this? This is strange. This seems to be some kind of bug in Godot. So let's actually remove this and instantiate our another water lane. Move it here. Yeah, now it's correct. And the position for this is minus 58, 1558, sorry. Then we have a turtle lane. Then we have another water lane. Let's see how I define this. 434, 100, 150. Rest is the same, and the position is minus 286. And then we have another turtle lane to finish this off. Let's see, this is 80, 175, turtle sections with 3, 2, 2, minus 480, minus 1. Oh, and this is almost correct, right? Seems that we should let's see, we should bump it up a little bit. This word lane probably by 16 pixels. Let's see. Or 42 pixels. Gonna be 62. And this is cool. In Godot, you can just do mathematical operations in the editor to move everything up or down. Oh, or was this good? And oh, my bad. The values were good. I just placed this in the wrong place because it should be in -350 in the Y. Okay, let's try this. We have logs and we have turtles. The definition for the last turtle lane is different though. It should be 322 80 175 and -1. Again, this is just a set of values that I have chosen, and you can see now that this is all working correctly. Cool. In our section, what we have to do is handle the death or our frog. Basically, if he gets hit by a car or doesn't land on the turtle or log, he should die. So let's handle that in the next section. Okay, now it's time to handle the collisions in our game and handle the situation where the frog goes into the water and dies or gets hit by a vehicle. Let's add a script to highway lanes. And let's place it in scripts. This is going to be very simple, but we basically need to know about everything that is going on in our game, and I don't really like this approach. Maybe it's good, but we need some kind of God script that knows about whole state of our game. So let's create new node, call this game state manager. Let's add a script to it as well. Okay. And here we'll create for now just a simple function called kill player that we will trigger every time we get hit by a vehicle. So in our highway lanes, in onReady, let's do highway lanes is equal to get children array of highway lane we will connect to that signal and say just get the reference to game state manager And if that happens, kill the player. Cool. So now we need to actually kill the player. And here we will get the reference to the player. And just say player die. And we need to implement that. Let's go to the bottom. And let's die. So first thing, we'll disable other collisions. So we need to get the reference to collision shape. We need to use set deferred. And set deferred, this is basically just to say set this property on that object whenever there's a time for it or whenever you're not busy. We need to set to stop the animation player. We need to set the texture for ourselves to depth texture. So let's grab this, Frogger dead. And I can just say, this should be on ready, right? Right, so on ready. Perfect, and then we can just say sprite to the texture is equal to depth texture. We can stop processing the input altogether. And we need a timer here to move our player back to its place. So let's add a timer. Def timer. I set this to 1 shot and 2 seconds. Grab the reference. And here I can just go def timer start. And we need to listen to timeout. And also we need signal. So signal life lost. This is fine. And on ready we can say def timer timeout connect on def timer timeout. Let's write that function. What should happen then? We should definitely emit the information that the life was lost, or maybe even decrease the amount of life. Oh, we don't have lives. Okay. Well, let's do export. And then we can decrement that. And then we'll also need another signal, game lost. And now, if lives are equal to 0, we also need to emit game lost signal. Else, we should reset the player. So let's write that function. Reset player. Set process input back to true. collision shape disabled is false. Sprite to the texture, we need to get the idle texture. So that's going to be progress idle. And global position has to be set to player start position, and new position has to be set to player start position. And that in theory should work. So let's try this. Hit me. Perfect. The timer runs out and we're back. So this is how we can get hit by the vehicle. Cool. Then we have to worry about hitting the water. So how to approach that problem? This is rather easy because we need to figure out, after we finish the movement, whether we overlap with anything else than water, right? Because if we overlap only with the water, then it means we jump straight into the water. If we overlap with anything else, or if we don't overlap with anything, this is fine. So after we finish the movement, we can get the overlapping areas by calling get overlapping areas, and this is like a built-in for area 2D, right? You can go to the documentation to check it. And then check the size. If it's 0, then we do nothing, right? Else, if we do not overlap we have anything else than just water, you can just simply write simple inline function. Then we simply die. Okay, let's try and read this. If any of the overlapping areas, right, is not water, and this is untrue, right, we die. So basically, if we overlap with water and the log, this is fine because it means we're on the log or on the turtle. But if we overlap only with water, this means we should die, right? Okay, and let's try this. So first we have to get past our cars, and we're here. Then I jump onto a log. Oh, and this was a problem because of the order in which we create stuff. So what we can do is just bump the z index of the player to 1 here in ordering, and that should fix itself. Right, we're on a log, so this is good. And then we're on the water. Try this again. And we're on the water and we're dead, but we can jump on the log. So let's see. Let's wait for the last log, and we made it to the top, and then we die. Okay, cool. So this is how we can detect whether our frog should die or not. Next section, we'll create the home slots for our wonderful frog to jump into. Let's build home slots for our wonderful frogger to jump into. So we will start by creating a new scene. The root scene is root node is area 2D. And we need a few things here. So we need 2 sprites. and this is going to be home frog sprite, and we need collision shape. Same this home slot. Save this, and let's start working on setting everything up. So for sprite 2D, we're gonna drag and drop home, set the filtering to nearest, and for the home frog sprite, we will get home frog. Also set to nearest. And I'm going to scale it down a little bit to 0.8 and maybe move it down a bit. Perfect. Then we can go to collision shape. Let's hide this for now. And let's set this like here is good enough. Okay, we need to add a script for it. This is going to be rather simple. Add a class name, home slot. We need the reference to home frog sprite, and as you can see, I keep it hidden. We need the signal, frog, and entered home. We will add a signal here for aria enter. You can connect it like this. Perfect. Pick the type. We will do frog entered home emit, and we will show the home frog sprite. Perfect. Then let's go to main and let's create a grouping node for that. So go to node, call this home slots, and let's start placing those. There should be 5 of them, and we need to place them in a very specific places so that we're sure that our frog can reach those. So let's instantiate home slot. Let's go to inspector, transform scale, set to 4 and 4. Okay, and let's start placing those. Let's see. -320, -412. Sorry, -412. Let's create another one. And this is -1 to 8. Let's create another one. And this is 1 to 8. And then another one, which is 3 to 0. To 0, and we can leave it as that. We have the 4 places, but we can also add a 5th. But to make it work, we need to scale it down a little bit, and then the place for this is, I believe, 2 or 0. Maybe we can bring it down a notch. Okay. So we have 5 home slots for our frog. One is smaller than the other, but this is due to the fact that we have to place them in very specific places where they can be reached by our frog, because the frog is jumping in the 46 pixel increments. Perfect. We need to add a script to our home slots node. Let's go to scripts. and we need to do a little bit of coding there. Very simple. Signal all home slots field. Home slots count is equal to 0. Field slots is equal to 0. And then we need to set up the signals. So get children as array of home slot count is equal to home slot size. For home slot in home slots frog entered home connect on frog entered home. Let's create that function. Oh. Field slots plus equals 1. If field slots is equal to home slots count, all home slots. Oh, it's wrong indentation, right? You can just emit the signal. Perfect. So what we need to do now is probably go to our game state manager and get the reference to home slots, and in ready function we need to do home slots. We can cast this, and to cast this we need to have a class name. Home slots. Good. Go back to here. Cast this. Cast this. Connect to that signal. With the player. Reset player. Right, for now this is okay. Let's see. Okay. Let's see one more thing, because when we go to a single slot, we should also reset the player, right? Bring it back to the starting position. So we need another signal here. Home slot field. So we'll do home slot field emit. Let's go to game state manager. So this is where we will show the, probably should do pass and a comment show win UI, and then here we should reset the player back to its position. Home slot on home slot field player reset player. Cool. And we can test it easily. The problem is that I don't want to jump through all the water and highway lanes, but I can just click on this and set the process to disabled, and also this, so we won't see it no more. Let's see. I'm just, oh, and I have to disable the water too because it's going to kill me. Then I jump and shot to show. Okay, try this again. Yeah, and I'm back here. Cool. There's a problem in the debugger. Let's see. Reset player. Oh, yes. We should do the same. Let's try this again. We don't want any errors. Perfect. So this is how we can put our frogs in home slots. Nice. What's left for us to do is to build the UI and build the timer. So we'll handle this in the next section. What's left for us to finish is to handle our UI. Let me just re-enable those nodes. Let's start with new scene. Root node is going to be canvas layer. Canvas layer. Perfect. Let's name this UI. Save the scene and let's go and configure our UI. So what do we need is first margin container. In theme overrides, let's push this off of the edge of the screen by 8 pixels. We will need few things. We're gonna need hbox container. Okay, let's see, are we making it? Let's push this to the bottom and full length. This has to be across whole screen. Okay, and then this should be then in the bottom. Perfect. What we need is another hbox container here. Let's call this lives container, and another hbox and call this timer container. Perfect. In the timer container, let's add a label and let's make it say time, and then add a progress bar. Okay. And let's push this container to the right, and alignment is set to begin. Container sizing on the hbox container here. Layout, fill, shrink, and this is correct. Alignment should be set to center. Okay, for the progress bar, we probably need to set the custom minimum size. Where is this? Yes, 400 to 30. Show percentage off. Max value is 40. Step is, this doesn't matter, but the value is set to 30. And now you can see it being filled. Right. But what we need to do is set the colors. So let's go to this is theme override, styles, background, and fill. Create new style box flat for both of them. The first one we're gonna make red. Okay, and then we're gonna do green. Perfect. This can be empty because we'll be spawning the amount of lives here. Let's see. This is correct. Alignment since the begin. And this alignment should be set to begin 2. Right, and what I was missing is in timer container, go to layout, container sizing, and click the expand to push it back here. Okay. And what we'll need also is a timer. I'm gonna call this timeout timer. Whenever it runs down, we will lose a life. Wait time 1. Okay, this is correct. And we can start scripting. So let's get rid of, maybe not all of it, but we need to connect everything correctly. So class name is the UI. Signal we will emit is timer runs out. And we need some references. First, we need lives container, but if I grab it like this, you can see this very nasty long path that's been generated for it. So instead, I can just access as unique name. If I do it again, get it like this. It's way better. We need reference to timeout timer. Label doesn't matter. We need the access to progress bar. Okay. On ready, let's do timeout timer, timeout connect on timeout, and timeout timer start. Let's write this on timeout. On timeout, new timer, a new progress bar value is equal to progress bar value -1. And I can do stuff like progress bar set value new progress bar value, and if new progress bar value, we don't need that, it's equal to 0. We do timer runs out emit timeout timer stop. Okay, we also need a function to reset the timer. So progress bar, set value 30, and we don't like magic numbers, so max timer value. Okay. And timeout timer start. Perfect. And we need to do something whenever the timer times out, and this should be handled in our game state. So let's go here. We need a reference to UI. Let's open the main scene. Oh, we don't have it instantiated yet. That's not a problem. Now it is here. Grab this and let's start working. UI as UI. Timer runs out. Connect. Kill player. Right? Because that's what happens. Okay. So let's see. Oh, it runs from the wrong end. We can fix that by going to UI, progress bar. Let's see. End to begin. And this should time out. And when it does, we can speed this up by setting the smaller values here, and this can be like some time to beat the level, so you can increase the difficulty of a level by scaling this value up and down, right? And we died. And yes, but we are not resetting the timer. So let's go back to our game state. We don't have, yes, we have to inform that we lost a life. So let's go to a player. Life loss and game loss. We have that set up, so we can just connect to those signals. Player, life lost, connect on player, life lost, and player, game lost, connect on game lost. I need to set those functions up. So on player life lost, we do UI reset timer. On game lost, we don't do anything yet, but we'll do something within the UI. And next one is to set our lives in our UI. So let's get back here. Where is code for this? Okay, we need to set the amount of lives in our live container. So let's create set lives function. It's going to take lives amount, and we know that this is an int. And we'll dynamically create a texture rect and add this to lives container. So for I in lives amount, let's create a new texture rect. And this is a little bit different because we do not instantiate it, but we call its constructor. So get texture rect, because I believe texture rect, well, it is a node, but it doesn't have instantiate, we have to call the constructor. Texture rect custom minimum size is a vector2 of 32 and 16. Texture rect, we need to set the texture, and for that we need to know which one to use. So I'm going just to say var live texture, and this is a preload of idle frog. So we have that, and also we'll stash this in our texture rect empty array. Okay, this is going to be live texture. We need also to set the filtering for that texture to be nearest. So texture rect texture filter is equal to texture rect texture filter nearest. A lives container add child texture rect to make it visible on the screen, and live texture live textures sounds like English is equal to, oh no, we just call append. Okay, so now we have to call set lives when the game starts. Let's see. We can go to our game state manager, the UI, set lives player lives at the very beginning, and those should spawn or not. Lives container non-existent function add child in base nil, and this is probably due to the fact that our UI is created after game state manager. So let's bump it up in our tree. Now we have our wonderful 3 lives, and if I'm killed, and oh, I do not lose a life, right? So we have to add that code. So let's go to UI, add another function, lose life texture is live textures pop back, which is going to remove it from the array and also return it. We just do live texture QE3. Let's try this again. And I respawn, timer is reset. Oh, and yeah, we have to call it. So kill player, and also this resets the timer and lose life. Now it should work. Nice. Perfect. What else do we need to do? We need to create some kind of very simple UI for the user when he loses all his life or he wins. And this is gonna be very, very simplistic. I'm not good when it comes to UI design. I'm not a designer, but nevertheless, we can set something up. So add a child node to our margin container. Is it in margin container? No, it doesn't have. Yeah, it's in the margin container. That's gonna be center container. Let's add a panel container to it. Let's add a see this. Let's set the let's set some kind of color to it, and it has to has a size, right? So let's make it 200 by 200. Cool. Let's add a B-box container, alignment center. Let's add a label with some text like you win in the center, and let's add a button. Let's just call it restart. Okay, this is like good enough for me. We will hide it at the start, and now it's time to code it. So let's grab a reference to it, and we need, let's call this game result label. Let's grab a reference to that too, and we can make it unique. Perfect. And we need to create two functions. Show win UI. Stop the timer. We say game results label text is you won, and we say it's center container show, right? And then we need to create show lose UI. They're very similar. We don't need that for now. Game results label text you lost, center container show. So they differ only in the text. What we'll also do is we will get the button and connect to pressed, and here we'll just say my favorite get reload current scene. Perfect. Now let's test those two. So to test our winning, let's go to main. Let's disable the water lanes. Let's disable the water. Let's disable the highway lanes. And in our home slots, we will say that the home slots count is set to 1. Okay. So we only need to fill 1, and nothing happens yet because we have to go to game state manager. We have on all home slots filled. What should happen there? We will just say player. We don't need to do reset, but we can just do UI show win UI. Try this again. Restart, it reloads the game. Perfect. What about dying? So let's enable everything back. Let's go to a player, change the amount of lives to 1, and let's get hit by a car. and nothing happens because we have to add this to game state manager. So on game lost UI, show lose UI. And it's going to work, but there's one problem that I really wanted to solve, and I spent some time figuring this out. You see, this modal window, let's call this, has the very same background for the lose and win condition, and I would like it to be red when we lose. So how can we achieve this? Let's go to UI. Let's find our panel container, and there's a very cool thing that you can do, which is make type theme variants. So let's go to theme. We need to create new theme, and then it pops up with this kind of additional theme window, right? And what we need to do to make it work, let's see, is to add new type variant. So let me see, how did I do it? I went to here and we need to add new styles, right? So one is for panel, standard panel container, and we override the style box here, styles and panel, and then I added another one, but I call this panel container red, and it's fine that it doesn't have available node base types. This is just a new custom type, and I added it, and here I chose base type. This time I'm setting this to panel container. Then here in the style I can add a plus, new style box, and here you can see that I have new style box flat that I can now change to red. So if we sum this up, in my theme I have panel container with let's add style here, the green color, and then panel container red, like a custom type, right, created here, and I can switch between those. So here in this window, what you do is you create your theme type definition, and then you fill it up here in the inspector, right? And again, panel container is based on the panel container, but this, as you can see, there's a difference in symbols here. This is custom type, but here when you have this wrench and screwdriver, I set the base type to panel container, right? And here it has none because it's already based on the panel container. And then it's gonna extend your editor so that here you can define the styles for both of your types, right? So I have a green for the standard panel and panel container red. This is my custom name. You can name it anything you like. It doesn't really matter, but base type is the panel container, and then it has its own red style. And with all of that, I can go back to my UI and simply say panel. Oh, I have to have the reference to panel container. Let's grab that. Panel container theme type variation is equal to panel container red, and this name has to match with this type. Okay, this is how dynamically you can easily change the style of your panel. Maybe there's a better way. If you know it, let me know. But now if I play and I die, what should happen is our model should be red. Panel container red. Did I make a typo? Panel container red. This looks correct. Oh, I need to get rid of the theme type overrides, of course. So here, let's just select clear. So not to override it. And now it's red. And you can restart. Cool. So this is pretty much the completed game. But now I lost my life. Okay. Let's try and get into the middle. And I won. Cool. So remember, this is not a perfect game. It misses a lot of features. There's potentially some bugs and a place to enhance and make everything better. But this should be blueprint good enough for you to start working on your own Frogger game in Godot 4. Thank you, and I will see you in the next episode.